When you're just messing around, when you're learning or prototyping or testing or whatever, we use a breadboard. It's easy to plug and unplug and put everything away when you're done. But some components don't fit in a breadboard and don't work well with a breadboard. Like these little switches I got that have these 6 terminals on the bottom with little hooks that are meant for actually soldering, mounting and soldering in a device. And they're spaced like a breadboard, but that's mostly just accidental. So I got 10 of these, which was just the size of the container, so I got 1 container to see how they worked out. So far they work pretty well, but I wanted to test them. 6 little legs here, how do you test that? Well, alligator clips are way too big, and I'd need 6 of them and I'd have to do it every single time. It would get to be a pain real fast. It'd be a miracle if I could get 6 clips on here without touching anyway. So I tried to make little wire hooks to put on there, and it was kind of working, but it was loose and it was still a pain. So I said, man, I wish I could just have a circuit board to put these in. But I'm certainly not going to construct something and solder and unsolder. And you say, well, 10, that isn't so bad, that won't take that long. Yeah, but what if I buy 100? It's good to know they all work before putting them in something and then having to disassemble something. So in a situation like this, you wish you just had like a socket on a PCB you could put it in and out. You wish you had a circuit board for just a few minutes. So I came up with the idea, and I'm sure whenever I come up with an idea, 800 people did it before me, but I did not Google it, I came up with it, so there. Why not mount tin foil, or aluminum foil, or aluminium foil, as you prefer, on paper or something, and just make a circuit out of that? And I call it a PCB because people understand the word PCB, even though PCB is a specific material. You get the idea, it's a circuit board. So you can make a temporary circuit board for something like this. But how? First, you'll need a sheet of paper. You can use cardstock. It would actually be slightly easier with cardstock, but I saw no reason to not just use what I had laying around. I would not use newspaper for this. It's a little too weak. But anyway, you want your paper nice and flat. If it's a fresh sheet of paper, it will be. So there you go. Then you want a glue stick. Just a regular old glue stick. I got it in the grocery store, office supply store, whatever. Just what the kids use in school. So what you do is you take a glue stick and you just spread a layer of this thing. They're cheap, so you can use a bunch of it. Just basically glue stick the page, not the whole thing, just, part of the middle, because you don't need a huge board. Just put a bunch of glue all over the middle of it, a nice thick layer. I doubt you can see it, but it's there. Oh, it's a little shiny, you can see the glue. So now you got some glue. Now, tin, aluminum, aluminium, metal foil. Standard stuff. Just pull you off a piece, put it down, and flatten it out. Just spread your hand, flatten it out. Nice and good. And then put the paper glue side down on it and try to not have any air bubbles. Just put it down and flatten that out too. Don't rub too hard because the glue makes it a little wet, so you could rip the paper. Just spread it out. Spread it out. There. And that's plenty sticky. We're not waiting for the glue to dry or anything. So now what you have is basically a glued region here and then loose bits. So just take some scissors and cut you out a square where that's all glued. Square or rectangle, of course. So now I have foil and paper glued together, and I cut it out of the middle so it's 100% glued. And remember the rule, always cut off more than you think you'll need, because you can always cut more off later, but if you cut too much off, good luck putting it back on. So now what you want to do is take your device and press it down on the foil to make an imprint of the contact points, so that you'll have a guide for actually cutting the PCB, cutting the circuit board rather. Always press a little bit firmly, but not too firm, because the idea is the foil and the paper and the glue is a little squishy. You want that squishiness. You want it a little springy. If you press too hard, you'll probably just flatten it out and it'll be harder to use. So just press just enough and not more. Press straight down. Always press straight down, because if you slide, you'll rip the foil. This is obviously temporary. It's not hard. I've done this. As long as you're careful, it's not hard. So you just take this and press straight down, very gently, but strong enough. And you should see imprints. If you don't see strong enough imprints, then move over a little bit. Like I said, cut off more than you need. Then move over to a new spot and press a little harder. Always straight down. There we go. So now what you'll see is nice imprints on the foil. It's not going to show up in this camera. Let's not fool ourselves. But that tells you where the contact points are. Now you want to cut off just barely enough to separate the contact points. You don't want to have little thin traces like you would on a real circuit board. You want to cut out little thin pieces, because you're not putting this down with precision. This is just going to be on a table and you're going to go like this. So you're going to want a little extra wiggle room to make sure that you're making good contact without having to sit there and use a micrometer to get it in exactly the right spot. So this having 6 contact points, basically, I'm going to want to cut 2 strips up like this. So we'll have like this and this and this and this quadrant will be contact points. And then the middle one will have 2 strips for the 2 middle ones. So the contacts on the 4 corners will have the quadrants. We'll just cut out enough to separate. And then the ones in the middle will have 2 strips. So now you want a blade of some sort. I recommend an X-Acto knife because it's for this purpose. But for me, I just so happen to have this really nice, super good box cutter that's quite sharp. The point is you want it really sharp. You could use a razor blade directly, but it's nice to have a handle. But basically, you're just going to eyeball it using the imprints, and you want to separate 2 different imprints by a very thin strip, just thin enough. So you'll need, a little bit down the middle to separate the 2 rows of 3 or 2 columns of 3. And then, like I said, you get the 4 quadrants and then the 2. Now, don't do this in your hand, do it on a table. But you don't want to press. You actually do not press down because you want to cut the foil, not the paper. If you cut the paper, it's not the end of the world, but it's going to be hard to use. All you want to do is literally just let gravity do the work. You have, the weight of the blade. This is a little heavy, so maybe if it had an X-Acto knife, you have to press a little bit. But just let gravity do the work. So put it down and slide it. Put it down and slide it again. And what you get is 2 score marks that should be on the foil and not the paper. Now, you can use the tip of the blade for this. You can use a tiny little screwdriver, anything, flat and sharp. Where in between where you made the score marks, where it starts, you just kind of push a little bit. Very gently, don't hurt the paper. But you just take the tip of it and you scrape just a little bit. And the foil comes up. Because the glue, right? The glue is not meant for this purpose. So it's not really adhering to the foil very well. Plus, it's fresh. It hasn't sat there for days drying. So you just get the foil up a little bit. You could grab it with your finger and you just peel it off just like that. And it didn't peel off fully. So I just take the blade right here where it started to separate and I just slide it again. Again, it's not cutting the paper. It's just pulling the foil up. Then I pull and now I have a separation just like that. And that's all you do. And this is actually thicker than you want, but this is just a demonstration. You just cut very thin separations, just enough to separate traces from each other. Because the glue and the paper are not going to be conductive, the foil is. That's it. Once you cut this, your board is done. So now let me show you, with the magic of a cooking show, the completed board I already used to test these switches, and how you hook it up. So here is my completed board. It's a little hard to see because it's shiny, but I've got 1 long trace down the middle this way, which separates the 2 rows of 3. It separates it into 2 sets of 3. And then I've got the 4 quadrants, which are for the outer 4 on the corners, and then 2 strips. And then I've got the 2 strips in the middle here for the middle contact point. So these 6 alligator clips are just on here. The alligator clips hook up to the parts of the foil that are conductive, and then it just goes over here to my breadboard, which I'll zoom out for in a minute. But you just have your switch and you just press it down this way. So if you just press it down on the foil, it'll make contact with the 6 sections of foil, which will then conduct to the alligator clips, which hooks it up to your breadboard for testing. Remember, always press just firmly enough to make contact, but not firmly enough to destroy the squishiness. And always press straight down so that you don't tear the foil. If you tear the foil, you might be able to fix it, but most likely you'll be making another board, which is just some more foil and paper and glue, but also time. So my foil is here. I have a test circuit set up in my breadboard, which is irrelevant. It's just whatever circuit you need. And I'll power it with 5 volts. And remember, we're working with the basic power supply here, so it's not dangerous to be handling the foil the same way it's not dangerous to just be handling these wires. You're working with 5, 12, 24 volts with skin resistance. Don't do this with wall power. Never work with wall power directly. But the power supply, as long as you didn't just get out of the shower, is fine. So this switch has 3 positions. If I put it this way and I touch it down, you'll see 2 lights go on. I'm just touching it to the foil and those 2 are on. I've got LEDs hooked up to transistors. If I turn the switch the other way and put it down, the other 2 lights come on. And you can see how easy it is to put it down and down. Oop, see? Gotta be a little careful. But because I left as much foil as possible and just cut out the tiniest bit, I don't have to be fiddly putting it down. I have margin for, handshaking. And then, of course, if I have it in the middle position, the switch is off and nothing lights up. And that's all there is to it. So now, to test a single switch, it's this fast. Position 1, cool. Position 2, cool, oh, cool, oh, cool. Sometimes it's not perfect, but I got it. And position 3, nothing on. Next switch. So if you're testing 2 or 3 switches, maybe this is not worth it terribly much. But if you're testing 10 or more, because I'm planning ahead when I buy more of these, because these seem to be good, if I want to test 100 of these, I'd rather spend 20 minutes than 20 hours. That's all there is to it. Paper, foil, a glue stick, and a sharp knife. You're not going to make a computer main board with this, and you're not going to make a circuit board that lasts the day through, but it's crazy quick. Once you know what you're doing, you just pound it out in a couple minutes, and you have the board you need to do some rudimentary testing. I guarantee that you could do this with something like a 16-pin chip as well. The problem is, now you got 16 alligator clips to mess with, and usually those are going to be dip and fit in your breadboard anyway. But if you're crafty, if you for some reason really want to, just got to be careful. I bet you could do it. So there is another tool for your toolbox, doing more with less. So I'll be seeing you.